This gravity-fed spring development pipeline and water tank system is an innovative water development that has increased utilization, helped to restore riparian areas, and maintains a consistent and reliable water source for livestock as well as wildlife. This development has been implemented in 3 phases, with the design being produced in 2008 and the final tanks installed in spring of 2021. However, Phase 1 implementation did not begin until the end of 2012. Upon completion of this project, the system included 27 tanks that are 13 feet diameter and cut for a 2-foot depth, 116,000 feet of pipeline which waters 8 pastures, and roughly 16,000 acres of pastureland with dependable water. This development is solely gravity-fed, with the elevation of the spring being 7,032 feet and the lowest tank on the system being at 6,140 feet. Prior to the installation of this development, the landowner faced issues with fully utilizing his pasture land. He was only able to use approximately half of his pastures due to the lack of consistent water. The previous solution required a lot of manual labor and a backhoe to dig out the water pits where the creek ran, which would allow the water to collect and provide a drinking source for the cattle. As with any livestock, this led to the overutilization of the riparian areas and lack of grazing utilization in the other areas of the pastures. As the landowner is very resourceful and land conservation oriented, he knew he needed to make a change if they were going to be able to keep these pastures at the carrying capacity of the land and forage. The landowner initially started this water development system by speaking with the NRCS district conservationist in his area. Cooperating agencies and the landowner spent numerous hours out in the field visiting these sites to map out areas where tank placements could be achieved. With the help of the NRCS engineer, the plan started to form in 2008. This included mapping of all the pasture fence lines, pipelines, and tank placements. NRCS, BLM, and the Small Water Project program through Wyoming Water Development were involved in the development of this livestock water system. In this specific location, there had been a spring that the BLM developed before the current landowner was involved. The BLM had placed a 24-inch culvert with half-inch holes in it near the head of the spring. The spring was producing roughly 4 to 6 gallons per minute, and through a little observation, the landowner noticed that part of the spring had been missed in the development or had slightly moved, and there was an opportunity for the spring to be fully developed. To redevelop the spring, they started by digging roughly a 3-foot trench from the head of the spring to the culvert that had been previously placed by the BLM. This trench was then filled with about 6 to 10 inches of gravel and a corrugated 4-inch collection pipe with holes throughout, and it was tied into the spring and laid on the gravel layer. This collection pipe was then connected to a 4-inch PVC pipe, and clamps were used to keep the two tied together. This PVC pipe was then ran into the initial culvert that had been placed through holes cut into the culvert. This setup utilized the initial development and increased the supply from 4 to 6 gallons per minute to 15 gallons per minute. The pipe was then covered with gravel and the trench was backfilled. This redevelopment helped to provide the adequate amount of water needed for this development to be successful and solely gravity-fed. The spring development was also fenced to eliminate damage to the infrastructure from livestock. After the spring was redeveloped and running efficient water, there was about a 4-year waiting period for cultural and other final steps to be finished from BLM. After this was completed, the project was ready for implementation. Looking down from the spring development, the first tank of the system to be installed is called a regulator tank. This tank is not equipped with a float valve, but instead with an overflow that runs into the natural drainage that the spring would run into, creating mesic water, a requirement for the NRCS design approval. Each of the tanks that make up the rest of the system are filled by the initial regulator tank. These tanks include float valves as well as shutoff valves. The shutoff valves provide for options on dispersion of cattle. If the landowner wants them to utilize part of an area more than another, he can shut one tank off and then the cattle will utilize pasture closer to the tank that is full of water. There are 10 tanks that are placed on a fence line, therefore providing water source for 2 different pastures. The tanks are placed and then split with the braces and boards you can see here, keeping livestock from entering the tank as well as staying in the correct pasture. Collection pipe and PVC pipe are used from the spring to the culvert. Then from the culvert to the first tank, there is a 3-inch PVC that ties into 1.5-inch black poly pipe. The poly pipe is used throughout the rest of the system and varies from SDR11 for the lower pressure areas and SDR5 for the higher pressure areas. The pipeline is trenched in using a cat and pipeline roller setup. The pipe is buried between 3 to 6 feet deep. The system was designed to have the pipe trenched in along ridges, existing roads, and 2 tracks to help minimize disturbance. In the system, it was critical to include drains that were placed at the low points of the pipeline. There were several drains installed to make sure that the water is drained after seasonal use, starting first at the headspring and moving down the system. The other aspect of maintenance is to remove the floats from the tanks, as the bears in the area think they are a fun toy, managing to break the rods if left. This off-channel water development system has dramatically increased the pasture utilization and has allowed for the successful rotational grazing management to be implemented. Before this development was in place, the pastures were overutilized on and near the riparian areas and almost no use in other areas. Today, with the rotational grazing practice in place, strategically placed water tanks, and dependable quality water source, the pastures are consistently showing more even use. Monitoring has helped provide data to show that in pastures that would have 10% utilization in places and 60% in others, have now evened out and are close to 30% utilization across the pastures. It has also helped to locate places where the landowner may add to the system with more spurs of pipeline and tanks to help get cattle to utilize certain areas when a water source is closer. Since the system has been implemented, the cattle are usually seen breaking up into groups 1 or 2 days after they have been moved into the pastures. This rotational grazing system is set up for 400 head of cattle. With the rotational grazing management, this water system will have between 4 to 6 tanks that are in use at one time. Since the spring is running roughly 15 gallons per minute, there is more than an adequate supply of water available. What will also assist is to have the overflow at the first regulator tank running into the natural drainage. This development has helped to improve the management to assist in conserving resources and improve riparian area conditions. It has made it possible to effectively utilize over 16,000 acres of pasture that were not previously utilized, implement a successful rotational grazing program, provide opportunity for cottonwood growth in the riparian areas that were non-existent before, and provide overall benefit to the land, water utilization, livestock, and wildlife.